There is a moment, if you have ever been truly alone in a wild place, when you realize something uncomfortable. You are being watched, not in the paranoid, imaginary way that urban anxiety sometimes produces, in the literal, physical, immediate way that comes from being in an environment full of animals that have been paying attention to everything that moves through their territory since long before you arrived. The deer you didn't notice until it moved, the bird that has been tracking your progress along the tree line from a branch you never looked at. The predator, if you are somewhere that still has real predators, whose eyes found you before your eyes found anything at all. You are the newcomer in this perceptual landscape. Every other organism in it has been operating in this specific environment, reading its specific signals for their entire lives and for the evolutionary histories of their species stretching back millions of years. And they are all, in their various ways, computing something about you, about what you are, about what you mean for their immediate situation, about whether you are a threat, a resource, a neutral presence, or something they have never quite encountered before and need to classify. The question of how animals actually see us is not just a fun curiosity about animal senses. It is a question with deep relevance to understanding the ancient human experience. Because ancient humans lived inside this animal perceptual world every day, navigated it for survival, and were as visible to the animals around them as those animals were visible to ancient humans. Understanding what animals are computing when they look at a human tells us something important about what ancient life actually felt like from both sides of the encounter and about the specific ecological position that ancient humans occupied in the landscapes they inhabited. Let's start with vision, because it is the sense that most people focus on first and the one with the most interesting cross-species variation. Human vision is good. Not exceptional by animal standards, but genuinely capable in the specific ways that mattered for the ancient human ecological niche. Trichromatic color vision, the ability to distinguish red, green, and blue wavelengths and their combinations, is shared with the other great apes and is relatively unusual among mammals, most of which are dichromats and cannot distinguish red from green. This trichromatic capability allowed ancient humans to identify ripe fruit against green foliage, to distinguish the subtle color variations in skin that signal health and emotional state, and to read the environment for color-coded information that most other mammals were missing. But here is what is interesting about how most of the animals that ancient humans regularly encountered would have seen them. Most large mammals see in two colors rather than three, and their primary visual adaptations are for movement detection and low-light performance rather than color discrimination. A deer, or a cave lion, or a woolly mammoth looking at an ancient human was not seeing the same visual information that the ancient human was seeing when they looked at each other. They were seeing movement. They were seeing contrast. They were seeing the specific silhouette and motion pattern of a bipedal primate, and that specific silhouette and motion pattern was carrying information about what this creature was and whether it was dangerous. The bipedal posture of humans is visually distinctive among large mammals. An upright walking primate moves differently from every quadrupedal large mammal. The specific motion signature of human walking, the characteristic gait, the arm swing, the specific rhythm of bipedal locomotion, is something that animals in human-inhabited environments evolved to recognize specifically as a signal of human presence. Even in low light, even at distance, even when color vision provides no distinguishing information, the movement signature of a walking human is recognizable. Animals that had coexisted with ancient humans long enough to build specific behavioral responses to human presence were computing their response not to a generic large mammal, but to a specifically recognized human stimulus. The deer's response to a walking human was not the same as its response to a walking bear because the deer's nervous system had learned, individually and in some cases over evolutionary timescales, that these two stimuli predicted different outcomes. Let's talk about olfaction, because in the sensory ecology of the animals that ancient humans encountered, smell was typically far more important than vision, and the ancient human olfactory signature was both powerful and informationally rich. Humans are, among large mammals, exceptional producers of olfactory information. The human body produces a complex mixture of volatile organic compounds from multiple sources: sweat glands distributed across the body surface, specialized apocrine glands concentrated in armpits and groin, bacterial metabolism of skin secretions, the specific volatile signatures of the foods recently consumed. and the specific compounds associated with emotional states including fear, arousal, and aggression. To an animal with a well-developed olfactory system, which includes most large mammals, many birds, reptiles, and virtually all the significant predators and prey animals of the ancient world, an approaching ancient human was a richly informative olfactory event. Not just human coming from that direction. Far more specifically, this specific human, with this specific individual scent profile, who has recently eaten these specific things, who is currently in this specific emotional and physiological state, coming from this specific direction at this specific rate of approach. The olfactory intelligence that prey animals extract from predator scent, and that predators extract from prey scent, is sophisticated enough to influence behavioral decisions at considerable distance and before any visual contact is made. Animals in environments with significant human presence learn the specific human scent signature and associate it with the specific outcomes that human encounters have historically produced. Prey animals in areas with high human predation pressure develop strong avoidance responses to human scent at distances that no visual or acoustic detection can match. This is why ancient hunters managed their scent. The documented practices of traditional hunters worldwide, bathing in specific plant materials to mask human scent, approaching prey from downwind, avoiding contact with strong-smelling materials before a hunt, are responses to the understanding that the prey animals they were hunting were reading their olfactory information before they were in visual range. Ancient hunters who did not manage their scent signature were announcing themselves to prey animals long before they had a practical opportunity to make a kill. Let's talk about what predators specifically were computing when they assessed ancient humans, because this is where the animal perception question intersects most directly with ancient human survival. A large predator encountering an ancient human group was making an assessment that was considerably more complex than a simple potential prey / not potential prey binary. The predator was computing a multi-factor risk-reward calculation that incorporated the specific characteristics of what it was encountering, the number of individuals in the group, the specific behavioral signals those individuals were producing, the presence or absence of fire, the specific acoustic environment of the encounter, and the predator's own history with similar encounters. Individual ancient humans, encountered alone, produced a different predator response than groups of ancient humans encountered together. The risk calculation for a predator considering attacking a single, isolated, unarmed human was dramatically different from the calculation for attacking a group of 20 humans with fire and weapons. This is the specific reason why ancient humans developed the specific social behaviors they did, the group movement, the fire maintenance, the collective defensive response, because those behaviors directly influenced the predator's risk calculation in ways that made individual members of the group significantly safer than they would have been alone. What predators saw in an ancient human group that they had encountered before, a group that had previously responded to predator presence with fire, noise, collective advance, and potentially projectile weapons, was not simply a collection of prey animals. They were computing something more like thing that causes bad outcomes when approached, the specific neural representation that a predator that had survived multiple encounters with organized ancient human groups had developed for human group was almost certainly associated with aversive outcomes rather than rewarding ones. This is the specific mechanism through which the landscape of fear operated around ancient human camps. Not that predators were incapable of attacking, but that their experience-built assessment of the encounter predicted poor outcomes and generated avoidance rather than approach. Let's talk about what prey animals were computing because this is equally fascinating and less often discussed. Large herbivores that coexisted with ancient human hunters were computing something very specific when they detected human presence. The probability that this particular encounter would result in an attack and the optimal behavioral response given that probability. And the sophistication of this computation across species that people tend to think of as simple, stimulus-response prey animals is genuinely remarkable. Animals in the high hunting pressure environments show specific flight initiation distances for human approach that differ from their flight distances for other predators in ways that reflect accumulated experience with human hunting strategies. They show differential responses to human movement that predict attack. A person walking on a predictable course generates a different response than a person who stops, which generates a different response than a person who begins to crouch or stalk. They distinguish hunters from non-hunters through behavioral cues. The specific quality of attention that a hunting human directs at them is something that prey animals have evolved to recognize and respond to. The specific way an ancient human moved and behaved when they were hunting was different from the way they moved and behaved when they were not hunting, and prey animals in environments with significant ancient human presence were learning to read those differences. The focused, quiet, downwind approach of a hunter produced a different prey response than the noisy, upwind group movement of a foraging party. The animal was computing the probability of attack given the specific behavioral signature of the human it was observing. This created a specific evolutionary pressure on ancient hunting strategy to produce the behavioral characteristics of non-hunting movement during the approach phase of a hunt. The stalking behavior of ancient hunters, the slow, careful, downwind approach that minimized the visual, acoustic, and olfactory signals that would trigger prey flight, was a direct response to the sophisticated perceptual assessment that prey animals were conducting on approaching humans. Let's talk about acoustic perception, because hearing is frequently more important than vision for the animal-human encounter in many contexts, and the acoustic signature of ancient humans was both distinctive and informationally rich. Most large mammals have hearing capabilities that exceed human hearing in both frequency range and directional resolution. The ability to rotate ears independently to triangulate sound sources, the sensitivity to high-frequency sounds that human hearing cannot detect, the ability to detect the specific acoustic signatures of human footfall and breathing at significant distances. These capabilities mean that the acoustic landscape around an ancient human group was providing information to surrounding animals well before any visual or olfactory contact was possible. The specific sound signature of ancient humans in a camp, the fire sounds, the human vocalizations, the movement sounds of a group of large primates in an enclosed space, was distinctive enough to be identifiable at distances that put the camp well beyond visual detection in typical woodland or savanna conditions. Animals at these distances were already classifying the acoustic input and computing their response before any closer engagement was possible. This created a specific challenge for ancient hunters that they addressed through acoustic management, the reduction of the sound signature of their movement during hunt approaches. Moving slowly, placing feet carefully, avoiding the snapping of branches and the rustling of vegetation, remaining silent, these practices were acoustic management strategies directed at the specific acoustic detection capabilities of the prey animals being hunted. The traditional knowledge of hunter-gatherer societies about the specific acoustic sensitivities of different prey species, which animals respond to which sounds, which frequencies trigger alarm versus which frequencies go unnoticed, what specific vocalizations can be used to freeze or attract prey animals, represents an accumulated understanding of animal acoustic perception that was developed through generations of observation and refined into detailed practical knowledge. Let's talk about something that rarely gets included in discussions of animal perception of humans, but that was deeply relevant to ancient human-animal encounters: the electric and magnetic sense dimensions. Several species that ancient humans regularly encountered have sensory capabilities that have no human equivalent. Senses that detect electromagnetic fields, electrical activity, magnetic field orientation, and other physical parameters that human sensory systems cannot access. Sharks and rays, encountered by ancient coastal humans, detect the bioelectric fields produced by the electrochemical activity of living organisms through an organ system called the ampullae of Lorenzini. A swimming human in shark-inhabited water was producing a bioelectric signature detectable by sharks at ranges extending up to several hundred meters under appropriate conditions. The human bioelectric field is not dramatically different from that of other similar-sized organisms, but it is detectable, and the specific field characteristics contribute to the shark's overall assessment of what is in the water. Many bird species possess magnetoreception, the ability to detect the Earth's magnetic field for orientation purposes. While this sense is not primarily relevant to bird-human encounter assessment, It is part of the sensory integration that birds use to navigate their environments and may contribute to the extraordinarily detailed spatial awareness that many bird species demonstrate. The ravens and crows that ancient humans regularly encountered. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. And that ancient humans regularly observed for the ecological information their behavior encoded, were operating with sensory integration that went beyond what ancient humans could directly access. For ancient humans living in close daily contact with the animal world, these non-human sensory capabilities were not academic curiosities. They were features of the environmental information landscape that had practical implications for hunting, navigation, and the reading of animal behavior as an ecological intelligence system. Let's talk about what dogs were computing, because the domestic dog, or the proto-dogs that began their relationship with ancient humans approximately 15,000 years ago, represents the most intimate and most consequential animal perception of humans in the entire ancient record. Dogs perceive humans through a sensory integration that is different from any other domestic animal. Their olfactory system is estimated to be between 10,000 and 100,000 times more sensitive than the human olfactory system. They can detect the specific volatile compounds associated with individual human emotional states. The cortisol-related compounds of fear, the specific volatile signatures of happiness and distress, with sufficient reliability that trained dogs can identify human emotional states through smell alone in experimental settings. The dog's perception of an individual human is therefore an extraordinarily detailed one. The specific individual human scent profile that persists across thousands of daily olfactory encounters builds in the dog's memory a representation of that person that includes their health status, their emotional state history, their dietary patterns, and their specific individual chemical signature in a detail that no human has of any other human. But what is most relevant for the ancient context is the specific cognitive adaptation that dogs appear to have developed specifically in the context of their relationship with humans. The ability to read human communicative signals. Dogs follow human pointing gestures, a capacity that wolves do not share, and that even chimpanzees show only weakly. Dogs track the direction of human gaze. They are sensitive to human emotional expressions in ways that allow them to respond to subtle human behavioral cues that wolves, their direct ancestors, cannot access. The proto-dogs that began their relationship with ancient humans were computing their encounters with humans through a sensory and cognitive system that was being actively shaped by the relationship itself, evolving toward greater sensitivity to specifically human communicative signals because that sensitivity increased their effectiveness in the mutualistic relationship. The ancient human was not only being perceived by the proto-dog, the proto-dog's perceptual system was being evolutionarily modified by the experience of perceiving ancient humans across generations. Let's bring this to the most important practical implication for ancient human life: how the animal perceptual landscape shaped ancient human behavior, and what ancient humans knew about how they were being perceived. Ancient humans were not naive about how the animals around them perceived them. The accumulated ecological knowledge of ancient hunter-gatherer communities included detailed, specific, practically applied understanding of the sensory capabilities of the prey and predator species they regularly encountered. They knew which animals detected them primarily through scent, which through movement, which through sound. They knew the specific flight distances of specific prey species in specific contexts. They knew the behavioral signals that communicated approach detection, the ear orientation of a prey animal that had heard something, the specific stance that preceded flight, the specific vocalizations that communicated alarm. This knowledge was not abstract. It was embedded in hunting practice, in the specific approach strategies used for different prey species, in the specific time of day and weather condition choices that experienced hunters made for specific hunts. It was transmitted through direct observation and explicit instruction across generations, becoming the deep ecological intelligence that traditional hunter-gatherer communities maintained about their local animal communities. Ancient humans were reading the animal perceptual landscape, using the behavior of birds and other sentinel species as an early warning system, reading the flight patterns of prey animals to determine the location and direction of predators, using the vocalizations of specific species as information about what was happening in parts of the landscape they could not directly observe. The animal perceptual world was, for ancient humans, a distributed information system that they were actively and skillfully reading in real time. And the animals were reading them back, computing their specific human presence, their specific threat level, their specific behavioral state. With sensory systems that accessed dimensions of information that ancient humans could not directly monitor, but that shaped every encounter they had with the animal world. Here is the full picture of what it would have been like to be an ancient human moving through a landscape full of animals that were continuously computing your presence. You were visible before you were heard before you were seen, smelled before any of it in downwind conditions. Every animal in the landscape that had coexisted with humans was running a continuous background assessment of your specific presence against everything it had learned about what humans meant for its specific situation. Prey animals were computing flight probability, predators were computing attack probability, scavengers were computing follow and opportunize probability, dogs were computing communication and cooperate probability. You were, in the animal perceptual world, a very specific kind of thing. Not a generic large mammal, not an ambiguous threat, but a recognized category with specific associated behavioral predictions that every experienced animal in the landscape had refined through its own accumulated experience. You were the being that carried fire, the being that moved in groups with coordinated behavior, the being that produced sounds that did not fit any natural template. The being that occasionally threw things from distances that made no sense. The being that the ravens followed, because where humans went, food eventually appeared. Ancient humans navigating this perceptual landscape were not invisible or neutral. They were central characters in the ecological drama of their environment, recognized, assessed, responded to, and incorporated into the behavioral frameworks of every significant animal in their world. And they knew it. They read the animal world's responses to their presence as ecological information. They managed their sensory signature in service of specific hunting and defensive objectives. They understood in the practical, empirical way that ancient humans understood everything important, that they were being perceived, and they worked within that perceptual landscape with the skill and knowledge of people who had been learning to read and be read by the animal world for hundreds of thousands of years. The animal at the edge of the tree line is not just an animal to be hunted or avoided. It is a sensor in a distributed information system that ancient humans were actively reading, and it is reading them right back, with senses they cannot match, computing conclusions they cannot directly access, making behavioral decisions that will shape the next moment of the encounter. Ancient life was a continuous negotiation between two perceptual worlds. Understanding that negotiation is understanding something essential about what it actually meant to be human in the ancient world.